Hello and welcome. This is Scott at MechSoft. This video presentation will give you an overview and a better understanding of the pocketing capability found in Alibre CAM. This demonstration part is an electrical box that will be machined out of solid material. As you can see, there are two distinct pockets in it, and I will create three pocketing operations to form these two pockets. To start the machining, I'll choose the Add-ons tab, Alibre CAM, then the Machining Operations browser, which comes up on the left of your screen. You'll notice that I've already created a preliminary facing operation to remove the material off the top of the part, which exposes the pockets so they can be machined. To create a pocketing operation, I'll make sure that I'm under the Program tab, then using the drop-down arrow on the 2-axis option, I'll select Pocketing. This will bring up the pocketing dialog. Now with this first pocketing operation, I want to machine this very shallow region where the lid of this main pocket will fit. To define the containment region for this shallow pocket, I'll go to the Alibre Design Explorer and select a sketch at the top edge of the pocket. Then return to the Machining Operations browser, and there is the reference to the sketch. For the tool of this operation, I have predefined two cutters. I will use the 26mm diameter end mill for this operation and will load the feeds and speeds that have been predefined with that tool. For the clearance plane, the system will check for the highest Z position of the stock, and I will add 6mm above that for all rapid traverse moves. For the cut parameters, I want the side stock to be 0 because I'm going to finish the walls. I want the cut pattern to be offset cuts, climb cut, and then start point to be on the inside. The step over will be calculated as 40% of the tool diameter. Now for the cut levels, when I originally selected the containment region, I selected it at the top of the wall. This parameter reflects that and must be set correctly. This means that the depth of cut will be interpreted as being below the cut region geometry. I don't know the full depth, so I'm going to use a built-in analysis function that allows me to select two parallel planes at the top and bottom of the pocket wall, which will then calculate the depth of that wall. Now let's look at the entry-exit. I want the tool to ramp into the material at 15 degrees directly above one of the generated cut segments of the path. For the retract, I'll specify a simple linear retract at 45 degrees. And now I'm ready to generate the path. And there it is. Now, since most of the parameters will stay the same, I'll immediately create another pocketing operation for the main pocket. Select the new one at the top of the main pocket, and this new region is entered into the Drive Regions list. I'm going to use the same cutter, so the tool, feeds and speeds, and clearance plane will all remain the same. Let's take a look at the cut parameters. I want the wall stock to be 0 to finish the walls. Again, the cut pattern to be offset curves, climb cut, start point on the inside, and the step over to be 40% of the tool diameter. Now let's go to the cut levels. As before, I selected the cut region at the top of the pocket. So make sure this is set correctly. And I will use the analysis function to measure the height of this wall as well. This is the total depth of cut, and I can break that total depth into roughing and finishing levels. This time I want a final finishing depth of 2 millimeters at the floor, and that will reduce the remaining roughing depth by that 2 millimeters. Now this roughing depth can be broken into sublevels. This parameter defines how deep each sublevel should be, and I want them to be 12 millimeters. And let's generate the path. Now for variety's sake, I'm going to create the pocketing operation for this second pocket by copying an existing operation of the same type. I will select the pocketing operation, do Ctrl-C to copy it, Ctrl-V to paste it, then drag the new operation to the bottom of the list and drop it there. And I'll rename that operation. Now I'll edit that new operation. I'll clear the regions list, and this time I'll screen select two sketches as the two new regions, one at the top of the pocket and one at the top of the island. These then are entered into the Drive Regions list. I will select the smaller tool. I will update the feeds and speeds to that new tool. The clearance plane will be the same. For the cut parameters, the stock will be 0, offset cuts, climb cut, start on the inside, and 40% step over between passes. Now again, let's define the cut levels. The cut region was selected at the top of the pocket. The full depth has been determined to be 38 millimeters. I want 2 millimeters as a finishing level at the floor, and that leaves 36 millimeters as the total roughing depth. And I'm going to break that up into sub-levels, each of which will be 8 millimeters deep. Because I have an island in this pocket, I'm going to set this Clear Island Tops option. Now I'll generate the operation, and there it is. I'll simulate this final operation and end the demonstration here. I hope this demonstration will help you to program pockets in your parts using Alibre CAM by Mexsoft. Thank you.